Growing up during the early days of the space age, Greg has had a long time interest in all things related to space, but he never really looked at astronomy as a hobby until fall of 2016, 9 years ago, when he happened on a class on the subject at the local community college put on by Don Machholz. Don who? Oh, yeah. Don't ever pass up a class hosted by someone with 11 comets named after them. He actually gave a couple lectures here. One was on um, the Messier Marathon several years ago. That class convinced Greg to get his own telescope, eventually focusing on the imaging of deep sky objects. On the side, Greg has been the one to tinker with all sorts of things, as you may have noticed by the topic of this talk, getting into 3D printing a couple of years ago in support of several of his hobbies. So let's welcome Greg. Yay. Yay.
Let's see, everybody knows what 3D printing is? Pretty much, yeah. Why this thing came about is there was Rod had a part that he was missing. I said, well, I'll print it for you. He said, what? Yeah, just give me the part number. And we created it. And then people started talking about 3D printing and all the wonderful things you can do with 3D printing. So why not give a talk on it as a general interest and kind of focusing on astronomy, this being the astronomy club, but it's really for anything. So quick thing about what it is, why are we talking about it, kind of how it works. You saw it working up here, but really what's going on. What things you can print, what things you can't print. There are limitations. How do you get the part into the machine? Right, you need some kind of a design or something. You can design your own, and then you got to print it. And there's various ways of doing that. And depending on time, we had a live demo. We had a live demo going over there, finished already. Or I can try designing a part and just kind of give you an idea what's going on with that. So we'll kind of wing it as we go. 3D printing, FDM, you may see that initials, is fused deposition manufacturing, modeling, FDM. You're manufacturing by gluing stuff together, by fusing material, as opposed to subtractive manufacturing, which is chiseling. So sculpture is a subtractive process where you're taking stuff away. People use like a lathe, a turning lathe, right? You're removing parts of a piece of wood. Chainsaws. Everybody's got a bear carved by a chainsaw, right? On your back deck somewhere. Subtractive. Another form of manufacturing is molding stuff, right? Pouring the liquid into a mold, let it harden. Plaster casting, resin casting. Three basic ways of manufacturing something. We're talking about fusing stuff together with 3D printing. You can extrude it, which is what we're doing here, making a filament nice and melted, basically, not dripping, but melted, and letting it kind of fuse together. Another way is by curing resin. Anybody been to a dentist recently and have them put some stuff in your teeth and then they shine a light on it? They're curing a resin in your tooth. Same idea, except you can do it on a scale of building parts. And believe it or not, you can actually go online, you can give them a design, and they will fuse it out of metal. You can make a ring out of silver, designed any way you want, and they'll manufacture it for you. So for all of your wives or husbands, plural, you can get them the same ring. Why do we care? Things break, things get lost. Like I said, Rod has one of the library telescopes, was missing the cover on the battery cover on the not the laser pointer, the red dot, the finder, red dot finder. It was missing you can't run anything without the battery cover on, hold the battery in. So what do you got? Well, he read me what kind of scope it was. I typed it in, downloaded the file for it, printed it, done. About an hour, took about an hour. Besides making stuff to replace things, you can add stuff to it. The part I just designed here or printed was a Batinoff mask. It's the easiest way to focus a telescope, bar none, except for unless it's fully automated. And you can print it. I printed that thing in about an hour. Make all kinds of utility things, brackets, clips, boxes. The very earliest 3D printers, you bought the basic thing, and it was so early in the industry, if you will, the science of it, they kept improving stuff. And instead of you buying an upgrade, they sent you a file and you printed it on the printer to upgrade the printer. So, where I got first introduced to this whole idea was in modeling. It's like you want to do a prototype of something, you want to make something. You saw the pictures that Robin had showing a telescope, or that globe of the model of the universe as they knew it back in the 1600s. Now you can pick it up and look at it and you can see what's going on. And I mean, it's definitely faster than Amazon, even Prime. It's certainly cheaper. I probably use more electricity tonight in printing that part than I did in plastic, especially in California prices. And there's no packaging waste, nothing to recycle. And it came with me. There's no transport cost for it. So, it's neat stuff. Think of this mental picture: a hot glue gun mounted on a crane that goes X, Y, and Z. And you squeeze out the glue as this thing travels around. How many people have done this at home, right? You got a hot glue gun. Everybody's filled in something by fusing hot glue with a hot glue gun. You just did 3D printing. Crude, but you did 3D printing. In our case, we have a thin plastic. It's about a little under 2 millimeters thick. It's squeezed through a nozzle that's about 1/10 of a millimeter thick, or opening, at about 200 degrees Celsius. That number it's an important number. And it squirts it onto the bed is heated to about 60 just to help it stick to it. Otherwise, you end up with something, well, I'll show you later. It got to adhere, the first layer has to adhere to the plate there. Besides, the plastic I'm using tonight is called PLA. It's actually made from corn syrup. It's a derivative of corn syrup. It's like nothing mined out of the ground. This is not, nothing from the petrochemical industry. It's actually from corn syrup. It's polylactic acid or something. It's biodegradable, all that kind of wonderful stuff. You can print with ABS, the black sewer pipe stuff. That really smells. Nylon, that PET, geometry, what that stands for, but it's a higher temperature, anything. And then that plastic can be impregnated with stuff. You can buy wood. It's plastic with a bunch of wood in it, wood fiber, carbon fiber, metal chips, it's just anything. And you can even get clear if you wanted to. So wide variety, go on Amazon or whatever shopping site. You got all kinds of different things that you can choose from. But plastic is still plastic. This isn't steel. You're not going to build a skyscraper from it, especially when things get hot. Now, the brand of PLA I happened to stumble on is from Sunlu. It seems to be really good stuff. The original stuff I got with the printer, yeah, it kind of warps in the heat and that kind of stuff. This doesn't. It's still PLA. I don't know what the difference is. Same price, different brand. So be careful of that. The other stuff is supposed to just get little in UV light. I've got some stuff that's been sitting out in the sun for 3 summers in Auburn, and it's still like new. So it's like, again, brands make a difference. There are limits to how fine precision you can do these things. This is 1/10 of a millimeter kind of stuff. On the resin printers, you can get down to really, really fine stuff. You can't do it like a knife blade with it or something, or you can't do a mirror, say, with it. But you get much finer detail with the resin printers. They tend to be more brittle, though, so they're trade-offs. I can do about a 6-inch cube on this thing. There are printers that are bigger. There's one that has the X and Y on the crane, and then the Z-axis is a belt drive thing. You can print something feet long. and it just keeps on going. They get expensive that way. And in terms of the parts themselves, you got to be able to do it by printing sequentially, building something up. If there's something hanging down in the middle, you got to figure out a way of supporting it from the bottom, because you can't print into thin air. Otherwise, you're just drizzling plastic all over the inside of it. That ain't going to work. So there's some limits for how the part has to be designed in order for it to be printed this way. But given those constraints, you can do some pretty neat things. Some examples. On the upper right there, that's that cap that I printed for Rod. I showed people the in the middle is a finder scope for looking at the sun. You don't want to look through your camera finder, your viewfinder at the sun. Bad idea. But this thing is equivalent. It's a little hole on one end, and it shines the sun on the other end, and it clips into the hot shoe of the camera. And when the shadow of the disk of the sun is in the middle of the back, you're aimed at the sun. Works perfectly. And then something a little more complicated. This is my telescope, the one I take to the star parties. I have an electronic focuser, which is a stepper motor that's driven basically to the focus knob. I just built a little bracket that sits in what would normally be the finder shoe there. And it just clips in there, built onto the fine focus knob. And then the computer software runs the thing back and forth watching the sky. So it's, the maximum sharpness of the background. So, you can do all kinds of things. You saw the pictures. Oh, I'm sorry. That's next. More examples. For left is a dew shield, I think it is, for the red dot finder that Rod did, and he did a size adapter from the 1.25" eyepiece down to the 0.76, whatever it is, that goes in one of the telescopes. So you can do that, and it'll cover top of the eyepiece on the far right. So a lot of things you can do there. Utility. And then saw Robin's pictures of the model of the universe as it was known back in the 1600s. And then fast forward a few years to a deep space radio telescope. So all kinds of things. Parts. Okay, you got to have a way of telling the printer what to print. What is the design of this thing? And we're in the internet age. You can go online. Two of the bigger sources, Thingiverse and Printables, both .com. You go and you type in whatever this image on the right there is from Thingiverse. You typed in Bahtinov mask, and it gives you a whole bunch of selections, a few of which are Bahtinov masks. Thingiverse's search engine is not the best, just put it that way. But I did find that, and I found, this isn't the one I printed just now, but it's also where I found the one that I just printed. Printables, another same idea. People design these things for their own purposes, and they upload them. Anybody else can download them if they can find them. And you download, it's an STL file. It's called a mesh. It's a design. It's a specification for what the part shape is. And then the printer knows nothing about shapes. All it knows about is X, Y, and Z, and squirting out filament. And so there's a program called Cura that slices the mesh file into layers that then turn into instructions for the printer to move and do its thing. And so the printer will print a layer, move up, print a layer, move up, and keep on doing it. Or you can design your own part. And we'll probably get through this pretty quickly. I'll give you a little demo of how that works. First things, guys, number one, if you don't know what you're going to make, you're not going to make what you think you're going to make, right? You're going to end up somewhere else. Sit down with a piece of paper and a pencil and a ruler, one of these caliper things, digital caliper. They work great. And you want to make something about this big. Okay, take it out. Figure out what it is you're building. Sketch on a piece of paper. Figure out where the origin is. Point at something, call that 0. And okay, this vertex is at 10 millimeters this way, 3 millimeters that way. Design your part on paper. Then you can bring it into the modeling software and make the same thing. If you start designing in free space, you're going to end up in a mess. And the biggest issue is that things there's a coordinate system where things get anchored to other things. And I'll go into a little bit. I'll demonstrate FreeCAD here. If you don't do it right in the right order, you end up with just a mess, and you can't undo it. It's horrible. Printing the part. What I showed you here was printing in PLA. ABS is it smells. Don't do ABS inside the house. In the garage, in the far end of the garage. I've never done it, but I hear it's really bad. The PETG is supposed to be really good for outdoors, hotter environments. Resin-based I talked about. There also are places you can go and get your part done for you. You don't need a printer yourself. Robin mentioned the Curious Forge in Nevada City. I wish she was here. She could give a little bit of a better description of what it is, but you can take your part designs to this place and have them print for you. There's a hacker lab in Sacramento. Apparently, the Nevada County Library has a facility. You can get certified on it, but somewhere in the back room somewhere, one of the buildings is a 3D printer. And believe it or not, at least some UPS stores, they've got printers. And I haven't seen one. This is based on internet search. But you can also go online. There are a bazillion places that you can send your design off, like getting something printed in gold or silver or titanium or whatever. Exotic materials, fancy designs, high precision stuff. Limited production, but more in the production versus the prototyping. A lot of these places online, you can do it that way. Where do printing it yourself is not that bad. At home, the printer. So that printer was in 2021, I think it was $279, not $2,007. It's $279 for that printer. They seem to be, I stand around 200 to in the 500 range. As you go up in price, you start adding features. You'll see printers you can put 2 different color spools on it, and I'll switch between them. You get printers that go faster. You get larger print areas, bigger bed, taller structure, fancier materials. There's one, you can actually add it, I don't know if you can add it to this one or not, a laser, and then you can do laser engraving of things with your 3D, run a laser around and do some wild things with lasers. Yes.
Why would you want 2 different spools?
Different colors. Just different colors. Yeah, 2 different spools, different colors. Or 4. They have a rack of like 6 different colors on them. And in your design, you specify which color for what part of the print, and it then pulls one out, puts one in, or actually they go into parallel heads, I think it is, and they move the heads back and forth and squirt it to the right one. One color. I have different spools I can put in, but it's one at a time. This is a entry-level printer. I say black is good for doing astronomy, but I just printed that Bahtinov mask in white, and it should work just the same because it's still opaque, and it's the diffraction grating in this case that is important. Other things to think about: PLA isn't quite so bad. Nylon is really bad. It absorbs water. It's like it's cornstarch, right? Corn syrup. It absorbs water. Well, the nozzle prints at 200 Celsius. What temperature does water boil at? A whole lot less than that. So as you're printing, it's getting this water in there and go with steam. And it's making a mess out of things as you go along. So you really got to keep the stuff dry. I bought a dryer. I didn't bring it tonight. It's a little plastic box with heating elements inside. You put your spool of stuff in there and you let it cook for 6 hours and boil off all the water, and then you can print. It's a limit to how much you can do with that. It's best to keep it dry. So it comes in a bag, and you put those little packets of silica gel. Keep it dry, and those well, that the thing I just printed with is at least a year old, so it'll last a while. Um, a spool of filament, it's about it's 1,000 grams, kilogram, right? 2.5, 2.2 pounds. A print, they're measured in grams. So a spool of filament lasts a long time, unless you build this, because a lot of these things that are hollow inside, they just make a little matrix just for support, but it's mostly air. So you're printing, I mean, it takes a while, but you're printing mostly air inside the part. So the filament lasts quite a while. And then there's also a little adhesive to spread on the plate, helps that first layer stay, the print stays stuck to the bed for the entire process. My very first print, well, so they give you when you buy a printer, they give you a couple of files to print, just to try it out. And that was a cat. It got up to, well, let's see, about a chin, I think, and then the bottom came loose off the plate, and the rest of it was just printed in thin air. So it's like, yeah, that's that didn't work too well. But let me show the folks online here. You can see there's that was supposed to be a cat. I'll send this around if you want to see what a cat looks like. What it's supposed to look like. So yeah, that's what that didn't have the adhesive at the time. You can buy a jug of this stuff, which is what I use now. Just as good as the glue stick. There's a washable, get the washable kind, a washable glue stick. You can just put a layer of glue stick on. Some people used hairspray in days gone by. They would spray with hairspray. Glue stick or this roll-on stuff works pretty well. And basically get the bed cleaned, put the adhesive on it, put your file. There's a little SD card that drives the printer with that G code. The most time-consuming and annoying part with this printer is leveling the bed. Now we're not talking level to the planet. We're talking there's the bed is a horizontal thing. It moves back and forth, and the head is this nozzle. The end of the nozzle is less than the thickness of a piece of paper away from that bed. Less than it. I mean, you use a piece of paper as a feeler gauge, and you rub it back and have it, and it's got to be able to stay at that level all the way across the entire as it's moving in and out and left and right. It's got to stay exactly that level. Anybody remember your Euclidean geometry? 3 points determine a plane, right? They got 4 adjustment knobs on this thing. Someone explain that to me. I don't get it. But anyway, you level the bed with the thing using a piece of paper as a feeler gauge. Get it exactly just snug, but not too loose. And then print. And off it goes. The nozzle, I have it set at 200 Celsius, the bed at 60. Those are the recommendations for this kind of plastic. Every plastic's got its own recommendation. They're generally in that range. Some don't need the heated bed, some need it hotter. The PETG prints at 220 to the nozzle. The plastic pipe that the filament goes through in the original, as it was received printer, melts at 220. So you can't do PETG with that. So I had to I bought an upgrade. It's a different plastic for the tube. What would they call that tube? Is that name for it? Anyway, that's the printer there. Level the bed and off you go with the printing. Ender 3V2 is what I got. That's the model. And the Sunlu printer, PLA, and the bed. Got a few minutes here. You guys want to see a actual part being designed? I use a program called FreeCAD. And somewhere on the desktop is the icon for FreeCAD. And one of the online, you can design these things online. There's a thing called Tinkercad. And Rod, I think, designed his parts with Tinkercad. It operates kind of the same way. So if I want to build a box, I start with a box. And let's see. And it's control to move it. Control right, there we go. Okay, so there'd be a box. And there's the coordinate planes. And okay, so it's like, let's make it 20 by 10 by say 5, just making up numbers here. So there's our little box, and you roll around, do all the fancy CAD stuff, right? But a box has air inside, so we do a subtractive. Oops. Okay, there's our box. That's a solid thing. To make the inside, we make a subtractive box. And this is negative material. And we can make it like, so if the length of it's 20, and I want 2 millimeters on all the sides, then instead of 20, it's going to be 1816 by what? Width is going to be 6 by, well, I made that a little too small. Maybe like 1 or something. Make it 2. So there's this negative area. It's kind of offset there. So we need to move it. Yes, that's what I need. So again, the coordinate system is the important part here. I skipped a step on the first one. Hang on. Let me go back to that first part. The model. Okay. Let's make it 10 by 10 by 20 by 10 by 10. And just so it's easier to deal with here. There's the top. Okay. So, okay. Now, the coordinate system, there's the XY plane. Okay. So I'm anchoring this part to the XY plane. And by doing that, now I can go back to the top, bottom, top. Okay. Now I can add that negative part. Again, XY plane is our coordinate system. And I can make it a bit smaller here. Let's do it that size, and we can go, oops. And we can move it, let's see, make it like that. And I'm used to my keyboard at home, and this is not my keyboard at home. Okay, now you can get the idea here. You move it this way, and it's too big that way, isn't it? This is why when you write it down, you don't have this problem. Now, if we do that the way it is there, you'll see what we ended up with is the hole is not centered right? So the offset, there we go. Do it to there. Is that better? Better. You can see what I'm doing here. What I'm trying to do. So you get the idea? And then, we can add a cylinder, and we can put a little knob on it. Oops. Okay. So now we've got a handle in the middle of nowhere. You get the idea. And just you build your part. And based on that piece of paper you did with all your design stuff on it. And then when you're done, file, export, and you export the part into an STL file somewhere in here. Wow. Somewhere here's STL. Anyway, I get the idea. Save the file, and then slice it and print it.
Now, would you print that one vertically so that the cylinder is coming up?
Very good. Question is, how are you going to print this thing for the supports is the problem, because this thing is out in thin air. So if you were to print it this way, with the bottom part down here, this thing is printing out in the middle of thin air. There's no position you can print this thing in such that something's not into thin air, right? Because if I make this edge here, if I print on this edge as the base, that thing grows up just fine. But then what do you do with this thing? So what you do in the slicing in Cura, you can tell your little tick marks is add supports. And what it will do is it'll build a tree of filament, very thin, going up to this thing, with barely enough filament on top for the new filament to attach to. And then when you're done printing, you break that away. And it can be difficult sometimes to break it away, but it can usually do that.
How much matrix of a filament does it have to put in for that?
The matrix it puts in is just whatever it needs. It figures it out. You can probably tell it parameters for how to do that. I haven't bothered adjusting them. You can print a little bit into thin air. So if the angle of this thing, like 45 degrees or less, more, whatever it is, no more than 45 degrees out, you can print, because the layers will overlap enough that it has something to sit on for 45 degrees. For more than that, then it falls off. But if you can limit your overhangs to no more than 45 degrees, you can actually print those. Here, if I made that a triangle, for example, at 45 or 60 degrees or something, it could print that. Yeah, good question there. So that basically is 3D printing. And again, you can download anything you want off Thingiverse. You can try bring that up if you want. Somebody name a part that you'd like to print. I'm not going to print it here, but just to show you the search function. What's a good part? Sorry? Car keys? Except for the chip in them, you probably could do that.
Some of the plastics you use are more flexible, right? So you can make things that are flexible versus really stiff.
TPM is it's not like rubber, but it's very flexible. So yeah, you can print in something that flexes. There you go, Radnoff masks. I forget which one I printed. There's the one that's in the picture that I showed. I think the one that I printed was for the C-Star 50. Mark, if you're listening, it's yours.
Thank you.
You're going to get it as a prize for today if you were here. But yeah, so it's a better Batnoff mask for the C-Star than the one that comes with it. So least that's what the thing said. But yeah, so you can print one, and then, sorry,
Kind of off the subject, but how do these work, the focus?
how does the focus? I'm sorry. Well, how does the Bahtinov mask work? Diffraction gratings. So, like you see a picture of the Hubble or the James Webb, little spikes on all the bright stars. That's because there's things in the light path that the light's diffracting around, and it creates that star. So you've got a grid in the mask. See the lines here, and then these are off at an angle. So you can end up with a cross because of the angled ones, and then a third spike in the middle. And the way that when you change the focus, that middle one is going to move back and forth. And so when you're in focus, you have all three intersecting at the exact same point. So you put the mask on, you go to a bright star, gotta be a bright star, and not a planet. It's gotta be a point source. Jupiter doesn't work. I tried it. It doesn't work. Go to something reasonably bright, and you'll see the three spikes, three sets of spikes, and change the focus, zip back and forth, put it in the middle, done. Takes about that long. The biggest problem is remembering to take the mask off of the telescope before you start taking the pictures. Yeah, how many people are taking a picture through a Bahtinov mask? Yep. Mhm. Yeah. So it's a great tool. And the one I've got for my telescope, I borrowed some construction paper from my kids and a pair of scissors, and I just channeled my inner kindergartner and just went at it and made a mask. And I went to Kinko's at the time and got it laminated. And then I realized that the transparent parts, not so transparent, didn't work. So I had to go back and with X-Acto knife and cut out the plastic parts. Just made a mess. I should print a new one, but it's the diameter is a little too big for this printer. So it's like we have questions. We have questions.
I guess some of the plastics are stronger than others depending on your application too.
Some plastics are stronger than others, definitely. This PLA, this Sunlu PLA, I'm not being paid by Sunlu, but it's amazing stuff. And I haven't. It's still plastic. So if you look at the bracket I did for the focuser, there are two screws that are to tighten in place, and they're bending into the plastic. It cost me all of an hour or two to print, and I can print another one. I can make it print thicker, less infill, basically, make it solid. I think I used like 40% or something infill. So I can make it solid, 100%. Or I could use a different kind of plastic. Or I could design it so that I could insert a metal plate where the two screws hit. That'd be the proper way of doing it. If you want to screw something together, you want to build something bigger, they make these little nuts that are, it's a little brass thing. It's got a screw thread on the inside and kind of a knurled outside. And what you do is you have a hole that you put in the plastic that you part of the design, a little smaller than that brass insert. And then you grab a soldering iron and stick it on the brass and heat it up, so the plastic gets hot and it goes zip right into the hole, and take it out, let it cool, and now you've got a brass insert molded into the plastic. And so you can screw something into it. The cheap way of doing a fastening like metal into plastic is just make a little block of solid plastic and just run the screw into it. It's plastic. Yeah. Other questions? Thank you very much. And printer's up here if you want to take a look at it.
One other thing, I noticed that some of the new ones, I noticed they have like a little cage around them, so they're completely encased.
So there are two kinds of that. One is for being really fussy about like air currents and stuff. I haven't had trouble with air currents on this one. The other kind are the resin printers, which that is, it's actually a fume hood, because the resin, when it smells. So it's yeah. They, in fact, my son-in-law has one of the resin printers, and he's got it mounted by the window. He's got a big tube that goes out the window. I think it runs the, yeah.
I got Andy, my older son, one of those bamboo ones, nice bamboo ones with
Yeah.
a cage and
Bamboo,
four
yeah.
colors and stuff. It's
The
pretty
other
good.
reason for that enclosure is you'll find that it's made out of like a yellow glass or a orangey kind, because it's a UV laser that's curing the resin.
Oh, okay.
And you don't want to look at the UV light because it's a damaging kind of UV.
Yeah, no, the one I got my son is, it's this
That's
type,
right.
but it comes in, it's got its own little cage
Yeah.
and fans and stuff.
Yeah, it's for air currents. And if you can do it with the laser engraver attachment, so you want an enclosure for that.
Yep.
Yeah, this one, it came this way. Some assembly was required, some more than was expected, but, yeah.
Like IKEA?
Much worse.
IKEA is easy. This was, I think the instructions probably are easier now. This is the version 2, version 1, I understand was worse, so.
When you say trouble with air currents, you mean just blowing the plastic one way or the other?
Cooling it. Air currents cooling the plastic, so it doesn't stick as well.
Or cooling it too fast?
Yeah. Cooling too fast.
ABS doesn't smell like that.
I've never tried it, I understand it's really bad, so.